All right, POE, we're going to begin our remote control car project, and this is going to take us probably about a week to do. This video is specifically designed for virtual students because with the amount of programming that we've been doing in class, it's going to be very hard to actually make a project even based on a design from your Chromebooks. It's going to be downright impossible. So what we're going to do is we're going to modify this a little bit, and all you're going to be doing for the virtual side is you're going to be designing the programming for having this remote controlled vehicle actually work correctly. So we're going to play a little make believe, and we're going to say that, we are working for clients at NASA, and the target consumer is the astronauts and the scientists at NASA. And y'all are going to be individual teams on this because y'all are just specifically working on the programming. So don't worry about physical construction. Do not worry about building. Once again, do not worry about physical construction. Do not worry about building. That's going to be just what we do in class. I'm going to show you guys how to actually do the um, programming side of this and what I'm going to be looking for you guys. And the problem statement is NASA wants a prototype vehicle that can pick up samples remotely and be able to store the materials inside the vehicle for later pickup. So we're going to be programming something virtually that will be able to pick up stuff and then be able to drop it off later. So it's going to be important that this thing be able to drive forward and backward. It's going to have to be able to turn left and right. It's going to have collision detection, which means that when it gets close to an object, it's going to slow down or stop, preferably stop. Even better if it backs up and moves in a different direction. So remember, if this is remote controlled and if it's NASA, you're not going to have the ability to just go over to the wall and pick it up or over to a rock and pick it up. So it's going to have to be able to turn on its own accord. Headlights that turn on. I don't know if we'll actually be able to put headlights on the virtual robot or not, but we're going to try to find out. And then be able to pick up a light rock and store it in a container. So there are some abilities to put up some rocks inside the virtual stuff. So I'm going to show you guys how to do this. I'm going to be requiring the 5 basic things for the setup. I'm gonna split this assignment up into 5 different sections. There's define the problem, and if you don't know how to define the problem, it's literally right here. Literally right here. This is the problem. Okay, so like, hey, gee, I wonder what kind of problem that we're going to solve. Oh, I don't know. Maybe we're going to find a prototype of a vehicle that can pick up samples remotely. Please actually turn this in. Okay, so the define the problem should not be hard. Generate concepts. I'm going to need some concept sketches or some ideas for how you're going to implement the programming. So if you just write out like, hey, I think I'm going to do it this way. I think if I plan it out this way, a flow chart might actually be a good idea too. And I'll try to make a video on flow charts as well. Develop the solution. You're going to actually be coding it. So I'm going to see the coding for it. The construct and evaluate will be like, I'm going to give everybody points for construct, so don't worry about that part. The evaluate the solution, you're going to show me a screenshot of your virtual robot that's actually done what it's supposed to do. So, and I'll make individual videos of this so that you guys can have them in each individual turn-in spot because I know that not everybody watches the entirety of the videos. Shame, shame. But, I'm going to go ahead and show you guys where to go for this. If you just go to Google, first thing that you want to type in is type in Vex VR. And when you hit enter, it'll say Vex code VR, and the website will be vr.vex.com. That is where you want to go. Click on that. And what it'll do is it'll bring up a window, and the window will have one of 2 different ways of doing things. So there's a tutorial so that you can actually watch the tutorial. I would highly recommend it. Basically, you get a little basic robot, and this basic robot you're going to be able to program from this website. So I'm going to go ahead and hit close. And there are 2 different ways to do this. Okay, if you are brand new to programming and you have not done this before, my best advice to you, and I know a lot of my programmers out there will not necessarily like me for this, but you're going to use these ribbons over here, and you can drag them on the program to create a flow of the robot actually working. This is called block code, and y'all probably have seen it before at some point in time. You can use block code for this project because Robot C, I don't have a compiler for you guys on the Chromebook, so there's no way that I can actually have y'all do this. So you can do this by dragging over the different commands, and they'll just kind of snap into place. So if you look at this, there are commands for the drivetrain, and there are specific ones. There is a command for the magnet, and the magnet will be able to pick up things and put down things. You can actually like print stuff out or set the print color. That is probably going to be extra for us. The control section is going to be a really good thing because we need to like wait times, repeats, if statements, if else statements. These are very good. Okay, and the sensing will also be useful as well too. So eye sensing, distance sensing, bumper sensing, drivetrain sensing. You can use these as well too. And the signal, the actual symbols here are related to the way that a flowchart would actually look as well too. So, and we'll kind of go over that later. So you can actually click and drag these in here and they'll snap into place. So if you wanted to drive forward for 200 millimeters and then stop driving, you just click and drag those in there and it will drive forward for 2 millimeters and stop driving. And then you're like, well, wait a minute, Mr. Broadway, how do I check and make sure that the robot actually did it? And I'm going to say, you know what? That's a good question. The answer is you can A, select the playground, and B, there's a start button. If you just hit the start button, it'll load up the playground, and it's going to default to like this basic, um, just flat grid all the way around. So, and the camera is looking from this way. You can also look at it from the robot's point of view. So sometimes if you want it to actually move, you can do that as well too. So then you can hit stop and it won't move from its location. So if you press start again, it'll move 200 more millimeters forward and then stop and then start. You can also use the step button and it will do it one step at a time. So these are all definitely useful for us. And you can also click on this button and it will get rid of the information up here. I do not recommend that. I would actually keep all that stuff up here so that you can actually see what's going on with it. The play button is down here as well too in the bottom left. You don't have to click up here. You can hit play and stop down here as well. Okay, and you can also hit the reset button and it'll take it back to its normal location. And then one more thing before I let you guys go. If you click on the playground button, oop, maybe I lied to you. Oh, yeah, up here. If you see where it says grid map, I'm going to ask you guys to use a specific one of these whenever we get to the actual task at hand. So I'll be a little bit more specific whenever we go into the construct and test and the evaluate the solution. So because you're going to need something to be able to pick up, and there's nothing to pick up here. So I'll give you guys some more information on that. That's what you're doing. So my recommendation for y'all Thursday, Friday, Monday is to look at this vexcode.vr. And also, if you want to, you can go to, there's also you can do new blocks project, and that's block code. And there's also a text project. I would only recommend doing text if you absolutely know what you're doing. I have a couple of people that are in programming class, and it would probably be to your best interest to do that. So I would appreciate it if you would challenge yourselves. But you know, you don't have to for this one. You could just use block code and that would be just fine by me. Okay? Y'all have a great day and I'll talk at you guys later.